is Jay Ball, and I'm the product manager for Seco Tools for the solid carbide round tool division. Today's episode of Cut View, we're actually going to be talking about high-speed hard milling. Now, I'm extremely passionate about this, and over the past 10 years, I've actually learned quite a few tips and tricks that you might not have seen published in any sort of catalogs or literature or anything, so I just want to go over those tips and tricks with you. There's probably about a dozen or so that you really need to take in consideration, but on this episode, we're going to talk about three. One is harnessing machinability, maintaining constant chip load, and minimizing your tool runout. Now, a typical hardened tool steel is roughly 48 to 65 Rockwell, and that's just looking at the end mill side of things. If you look at an inserted application, there's probably more in the 35 Rockwell, maybe low 40s is considered hard, but just for the end mills, it's about 48 to 65 Rockwell. Now, you do have to keep in consideration the material you're machining. Not all hardened tool steels are the same. For example, D2 is about 60 to 62 Rockwell typically, but because of the chromium content, you actually need to treat that material like it's 62 to 65 Rockwell. For those of you that machine vanadium, such as CPM 3V, 9V, 10V, you have to be mindful of the particle hardness because the surface hardness of that material is roughly 60, 62 Rockwell, but the particle hardness can be upwards of 70 Rockwell, so it's extremely hard and extremely abrasive. So a rule of thumb for machining vanadiums and CPMs, whatever the Rockwell is, treat it like it's a group higher than that when you're calculating your cutting data. Now, a material that's actually caused a lot of heartache for a lot of guys with this years I've been doing this is a material called copper tungsten. That's an electrode material that's used for machining carbide packing dies. And what'll get you is the fact that it says copper, but you also have to be mindful that there's tungsten in that material, and the tungsten makes it extremely abrasive. So as far as cutting tools go, I actually recommend cutting tools that are designed for doing 46 to 48 Rockwell, and then also the speeds and feeds to go as well. So just keep that tip in mind when you're machining copper tungsten. Now, maintaining constant chip load is a big thing that I see a lot of people struggle with, and the problem is when you get into high-speed machining, you're using 30, 40,000 RPM machines, you want to run max RPM and max feed rate. But depending on the size of the detail of the part you're machining, that's going to limit you how fast you can feed. So my rule of thumb is if you cannot maintain your program feed rate for 80% of the program cycle, you need to reduce your RPM to maintain a more constant feed rate. For example, if you're running a 30,000 RPM machine, you program for 300 inches a minute, but the machine can only maintain about 150 inches a minute for 80% of the cycle, and you reduce your RPM to 15,000 so you maintain a more constant chip load. You can have a huge increase in tool life with a very, very small difference as far as cycle time goes. Now, this concept doesn't just apply to hard milling, it also applies to machining graphite electrodes too, so keep that in mind when you're machining your electrodes. Now, one of the biggest things that I've seen customers struggle with also is minimizing the tool runout. They spend $250,000, $500,000 on a brand new high-speed machining center, and then they buy cheap holders. Don't go cheap on your holders, folks. I suggest shrink fit tools, hydraulics, milling chucks, even our side lock holders from Seco give you less than 2.5 tenths runout. But anything more than 4 tenths is going to actually cut your tool life in half. Now, everyone knows how small 4 tenths is, so please keep in mind that anything more than that is going to cut it in half. Now, don't forget that the mini tools we offer, say a 1/2 mil or 0.2 ball nose, those chip loads can be around 2 to 4 tenths. So if you have more than 4 tenths chip load, you're doubling the chip load, and you're going to wear that tool out prematurely. So those are just some tips and tricks that I've learned. Like I said, there's about a dozen more. On the next episode of Cut View, we're actually going to talk about avoiding excess finish stock, utilizing programming and software, using the right tool and coding, but then also taking advantage of the support that a lot of suppliers give you. So appreciate you guys tuning in. If you have any questions, please contact the tech team, and thanks. Have a good day.